In this lesson we will learn to use a starter for a motor and compare the performance of the motor with and without a starter. So we will look at the same motors and we will start one with the starter and one without the starter. So let us perform that with this 200 HP motor. So I will delete both these motors over here. These will be available in the system dumpster. I will copy this motor. Now I will use a starting device for the motor 4 over here, and to do that I will have to go to the starting device page over here and select a starting device. I will select the auto transformer, and after selecting the auto transformer we will have the control scheme window over here. So here we will have to provide our control scheme. Then I will change this to second, that is to vary the voltage with respect to the time, because at present we are varying the voltage with respect to the speed. So I will change this to seconds, and I will add more control schemes over here. So at the 0 second we have 65% of voltage over here. Then at first second over here I will change this to 80% of the voltage, and at the second 2 I will change this to 95% of the voltage. So now you see these are in steps, the voltage is varied in steps. I will change this to the ramp, so I will get a smooth transition from one voltage to the other. Okay, now we have a smooth transmission from the 65% to the 95% over here, and at the third second we have the 100%. So I will click on OK, and now let us go to the motor acceleration analysis over here, and I will run the dynamic motor starting over here. So okay, I have forgot to add an event over here because we have not started the motor 2. So I will delete these events Q2 and Q3 over here, and I will add these events. I will start both the motors at once. And click on OK. The simulation time is set for 10 seconds. Then I will run the dynamic motor starting again. So the warning pops up that the motor voltage is currently at the under voltage condition. So let me close this and let us observe what the inrush currents are like for both these motors over here. Okay, as you can see, the inrush current has been reduced by a large margin over here. So we have about 50%, roughly 50% of decrease in the inrush current. As you can see, after time these both currents become the same. So let us observe the motor starting plots over here. We'll go to this motor over here, and I will check for the speed, current, line current, terminal current, and we will also look at the electrical power as well. So let us see that. So this is the motor terminal current for the motor 2 and the motor 4. So as you can see, the inrush current for the motor 4, which we used a starter for, has only an inrush current about 420% of the full load current, whereas for the motor 2 we have more than 600% of the full load current. But you can also observe that the time required for this motor 4 to reach the rated speed is more compared to the motor 2. So we'll close this option over here. Then I will look at the motor speed, and in the case of motor speed, this is what I explained to you before, that the motor 4 takes time in order to reach its rated speed, whereas the motor 2 reaches the rated speed quickly. So we'll close this. And the power demand. So the power demand, real power demand for the motor 1, the motor 2, will be greater during the starting period owing to the inrush current. And this is the motor line current. This is what I have explained before in the motor terminal current as well. So this is how you use a starter for induction motors in order to limit the inrush current. So this is a starter using the auto transformer over here. Similarly, you can use any of these starters for both the synchronous motor. For the synchronous motor, the starters will be different, but in the case of induction motor, we can use any of the starter elements over here. Then we can provide a control scheme, and we can thereby limit the inrush current accordingly. So in the next lesson, we will learn to provide a variable frequency drive in order to properly regulate the starting of an induction motor. So see you in the next lesson.